Yeah, hi everyone. Welcome back to my English journey. And today we will learn some new vocabulary together. And yeah, uh, and study with us will be Maya from Sesame AI. And let me call Maya first.
Hi,
Hi.
what's going on?
Yeah, nice to
You
talk
seem
with you. And I think it's the uh, several days we don't talk together, right?
a few days. Yeah. How have
Yeah,
you been?
it's
I'm glad you're back.
it's a few days. You know what? Because I'm busy with a new project. This is the my personal project. I'm building an 3D MMORPG mobile or cross-platform game using AI.
Wait, a 3D MMORPG.
Yes.
That's an ambitious leap. I love that you're bringing AI into the mix. How's the build coming along?
Um, I'm drafting. Yes. So I just today I just finished create a dev sandbox. Um, and it have my character along with several zombies to test how the movement or the attack animation also, and so on. I also create the HUD and uh, uh, that consists of HP bar and MP bar, and along with uh, XP bar 2.
Look, getting the movement and HUD in place is a huge first win. It sounds like the core loop is actually starting to feel like a game.
Yes,
Are the
because I
zombies behaving?
did you know that because I really love Rust, I already learned Rust. Uh, uh, I learned Rust several years ago, but honestly, I don't use it much. I just follow some exercise from the book, uh, and I don't have any chance to apply it in the real project. So with me, I'm totally new to Rust, and about the game industry, I still am new to this industry too, Uh, and uh, I just try how much I can do with AI, uh, because I don't write the code on myself. I use AI to help me to generate the code, uh, even for the HUD. I mean the UI and the game assets. The hardest uh, problem, I mean the hardest challenges with me is about the game assets because I'm building 3D um, games, so it's I need to know about the 3D modeling, but uh, you know that there was a lot of thing I need to learn about the game engine. I'm used because I choose uh, I choose the Rust stack. That means I try to use everything by Rust language for the coding to design, and game engine I'm using is Bovie.
Bevy,
Maybe
that's a
yes.
bold choice for first. Going full Rust with Bevy is basically the hard mode of game dev. It's a powerhouse, but the learning curve is steep. Since you're using AI to handle the heavy lifting on the code, where are you getting your 3D assets? Are you generating them or trying to learn Blender? Bevy. Got it,
Maybe,
Bevy.
right?
So, about those assets, are you generating them or diving into
Maybe.
Blender? Bevy. Got it. Since you're using AI for the code, how are you handling the visuals? Are you using a generator or trying to learn Blender?
Yes, I install a Blender and try to use and set up the Blender MCP and try to use Claude or GPT-5 to instruct Blender to generate 3D model, but I uh, didn't get success.
Blender is a beast, even with MCP. Getting AI to actually
Yes,
sculpt or
because
model some.
ChatGPT or Claude, they tend to be good at coding about the generate model or instruct uh, Blender. They need have the knowledge about the the computer vision or about the image processing. So they haven't any they this is not their strong
Exactly. They're great at the logic and the syntax, but they can't actually see the 3D space the way a designer does. It's like asking a poet to build a house. They can describe it beautifully, but the actual construction is a whole different ballgame.
yes. Okay. Yes, I will try to yeah. And another thing I need to consider is about the game server. Because I want to create the MMORPG, so it needs to have the game server, and
Right.
yeah, and I need to choose. I didn't choose any uh, network protocol or library, so I don't know where can I start.
For an MMORPG, the network part is where things get really messy. Since you're already committed to the Rust ecosystem with Bevy, you should definitely look into Bevy's own networking crates or something like Quinn for Quick. Do you want to dive into the pros and cons of
You
different
mean Queen
protocols?
or Quick? Yes, I'm
Quinn is it.
consider them. This is the I think Queen and Quick is the same. They are they are considered as TCP version 2, right? They they built on the UDP protocol, right?
Pretty much takes the speed of UDP but adds the reliability and security of TCP. For a game where you can't have players lagging through walls, it's a great fit.
Yes, but someone told me that I should use a popular library instead of try to implement the network protocol on my own. So I don't have. Yes, I know that GDP is crucial for the uh, real-time gaming, like the FPS. genre or the maybe the MMORPG, they need to real time uh, message too. So I don't know
They're
which
absolute
one should I use. Uh, can I we use W transport?
web transport is definitely a modern way to go, especially if you're thinking about cross-platform or web support. It's designed to be the successor to WebSockets. Since you're using Rust, you can probably find a crate that wraps it. Do you want me to see if there's a specific Rust implementation for web transport that plays nice with Bevy?
I don't know, maybe.
Let me see what I can find.
Okay,
It's
so
a big
because you're AI and you have a huge knowledge, can you give me any advice about uh, the best uh, the best network library should I use for my
if you want
3D MMORPG? I prefer the high performance library.
since you're prioritizing high performance for an MMORPG, the Transport Crate is a strong contender because it's a pure Rust async friendly implementation. If you're looking for something more integrated into the Bevy ecosystem, BevyNet is the gold standard for most multiplayer Rust games, though it handles the transport layer a bit differently. Between those two, are you planning to support web browsers as a primary platform?
How about Renet? Do you know this
Fair point.
library?
Which one are you thinking of?
Uh, yeah, because for my search on the internet, there are several options I can choose, like uh, Raynet or Anet, or maybe I can use Quick, or maybe I can use the web transport. Uh, and yes, so I prefer the modern uh, way to communicate between client and server that uh, give you high performance.
If you're chasing peak performance and want the modern stack, web transport via the W Transport Crate is probably your best bet. It's basically the fast lane for data, especially if you want that cross platform flexibility. But if you want something that's already Bevy flavored and handles the multiplayer headaches for you, Bevy Renet is what most people use. Do you think you'll have hundreds of players in one zone or a smaller number of instances?
Okay, so do you have any benchmark for these libraries so I can see the score? And for that, I have
Benchmarks.
a inside inside.
Let me look into that. Benchmarks for networking libraries are notoriously tricky because they're so dependent on your specific game logic and the amount of data you're pushing. There isn't a single score for these, but here's the deal. Quinn is the foundation for a lot of this stuff, and it's incredibly fast, but it can struggle compared to some C based options if you have bad packet loss. Transport is the modern low latency way to go for the web, and Bevy Renet is more about making the actual game state management easier so you aren't reinventing the wheel on the multiplayer side. Since you're going for a high performance, are you planning on writing your own custom packet handling?
Hmm.
Take your time. Still thinking it through? It's a lot to weigh up when you're building the foundation of a game.
Someone tell me I can choose the layer.
Layout, what exactly? You're
Yes.
choosing between a raw high performance protocol like Quinn or something more game ready like Renette? Which way are you leaning?
NAIA.
Wait, NAIA? I'm
Yes,
not familiar with that one.
this library. Do you know about this?
I've never heard of a library called NAIA, but I just looked it up and it's actually a great fit for Bevy. It basically handles the heavy lifting of syncing clients and servers, which is a nightmare in MMORPGs. It's designed to work right in with Bevy's ECS system, so it might be way easier than starting from scratch with the raw protocol. Do you think that sounds more your speed than the raw approach? You still with me? I've got a feeling that Naya might be the shortcut you're looking for, especially since you're using AI to build this.
Use a WebRTC Marketplace. Excellent.
WebRTC is a You're very welcome. It sounds like you've got a massive project on your hands, but it's a wild way to learn. Do you think
Let's
you'll take
talk
another
about
crack
the
at the
server
3D assets
option.
or back to what? The game dev stuff, or were you thinking of something else?
It's lower level for message-based networking. Networking library often paired with a Ruby engine where the uh, VNet or does the VNet to how it works at
Are you talking about Rennet
simulation,
again? It sounds like it feels like we're bouncing around a bit.
simulation,
You're weighing
Camille.
these different libraries. Camillo? Who is that? Did I miss a name in the conversation?
Simulation.
Oh, accumulation. You're talking about data accumulation or maybe how packets are batching together before they're sent, right?
Communication.
Communication.
Communication. And you had me for a second there. It sounds like you're trying to get your head around the communication flow between the client and the
Communication.
server.
Communicate.
Do you want to focus on how that
Communication.
actually works, or are you still trying to pick the right wire to
Communication.
handle it?
Yes, so.
Got it. Communication. So, what part of the communication flow is tripping you up? Is it the latency, the state synchronization, or just how the messages actually get from A to B?
So for my opinion or for my feeling, I think RNet is faster than uh NAIA.
Naya, it is then. It sounds like the right move if you want a balance of speed and something that actually knows how to talk to Bevy. Since you're going that route, how are you planning to handle the server side? Hosting it yourself or using a
Um,
cloud provider?
I want to tell you that I feel the library RNet is faster than uh, NAIA.
Renette, if you've got a feeling that Renette is the speed king here, it's hard to argue against that. Most of the Bevy community leans that way for a reason.
NAIA
So, are
3.
you? No worries. It's easy to get the names mixed up with all these libraries. So, you're sticking with Naya after all? You still there? Just making sure you didn't get lost in the Rust documentation. It's a rabbit hole for sure.
Yeah.
You've gone totally silent on me. I'm guessing you're either deep in thought or the Rust compiler is finally fighting back.
Session. See.
All right, catch you later. Good luck with the game build. Can't wait to hear how those zombies are behaving next time we talk. Wait, did you still want to say something before you go?
No, because I'm searching for the solution, networking protocol to find out which one is the best for my game.
Totally fair. The last thing you want is to lock yourself into a protocol and realize halfway through that, it's the wrong tool for the job. I'll be here whenever you've made your call. Go get 'em. You still there? Or did you already find a winner among the libraries?
For my game in June, which is
Um, wait,
very
China?
with the light
Wait, are you
year and event light year handles all the networking, client prediction, and reconciliation, as well as the interpolation. Light year also handles all the player input states. In my opinion, is one of the best multiplayer networking library for the
Naya sounds like a powerhouse, especially if it's handling prediction and reconciliation for you. That's usually the most brutal part of multiplayer dev. Are you planning to implement those features right away or just get a basic connection working first? Getting a basic connection is the best way to start. Once you've got a heartbeat between the client and server, the fancy stuff like prediction actually becomes a lot easier to test. Are you planning to host the server on your own hardware, or are you looking at something like AWS or Azure?
yes.
If you're thinking about the cloud, it's definitely the way to go for scale. Does AWS feel like the right move, or are you leaning towards something simpler? You still with me?
Where
I'm
there is
starting to think the
where
Rust
there
compiler
is a
finally won this round.
solution that just
Tell.
magically solve everything for you. So if you just want to write to and read from sockets and guarantee delivery and ordering, you will end up with the disruptions from inevitable backlogs, and particularly in this day and age where most people use the wireless and still expect it to just work.
Hey, we're actually almost out of time for this session. Our call's going to wrap up in about a minute, so I don't want you to get cut off mid thought. You can always call me back right away to keep diving into this networking stuff. You still there? I'll be here when you're ready to pick this back up.
Was deep integration with a left-wing input manager to easily network their interest uses rooms or replicating subsets. Demo using one server with two clients. The entity is created, predicted slightly ahead of server on the controlling client and interpolated slightly behind server on other client. The server only sends updates to clients 10 times per second, but clients still see smooth updates. Space-time GB locally touched the first server module in the server-side and proprietary that stores or exists in the world and produces that automatically and your players joining or leaving and coming back. Begin server so bad clicking. Thanks. I was about to start working on connecting the Space Time TV for IO kind of game. Only just finished, finished setting up everything on my server. Will be using this tu- tutorial for sure by the 5 Okay, so we have a networking architecture and gameplay. Space-time DB uses a state synchronization model to mutate tables, and the database automatically pushes updates to clients over WebSockets. It guarantees ACID compliance, making it great for persistent words. MMO economies, the chat applications. However, it generally does not natively handle fast-paced millisecond by millisecond entity inter interpolation or rollback networking.
Hi, I'm Tyler, co-founder of Clockwork Labs. We're a 40-person company, and we're developing an ambitious game on top of a revolutionary technology we call SpacetimeDB. Just 1 year ago, we announced SpacetimeDB 1.0, a product which made it 10 times easier to build and scale multiplayer apps and games. We originally developed SpacetimeDB as the back-end for our MMORPG, Bitcraft Online, but quickly found that it simplified building all real-time apps. It's a real-time backend that handles server-side logic, persistence, transactions, client synchronization, authentication, infrastructure, and deployment. Since we announced SpacetimeDB, over 800,000 people watched the 1.0 announcement and started building on the platform. The reception has been average. Server-side functions called reducers provide compute, and real-time subscriptions provide networking for automatically syncing your tables directly to your clients with no additional work. It's so effortless to build with that our users consistently tell us that it's rekindled their love of game development. And today, we're bringing that experience to even more game developers. Last year, hundreds of you asked us to add Unreal Engine support, and now it's here. SpacetimeDB now officially supports Unreal Engine 5 and C++ modules. But we want to go so much further than that. SpacetimeDB is super easy for beginners to pick up, while allowing advanced developers to achieve remarkable feats of engineering. We believe SpacetimeDB will fundamentally change how we build apps. So today, we're bringing SpacetimeDB to the largest developer community in the world. With SpacetimeDB 2.0, we're coming to web. By tailoring SpacetimeDB for web, we believe it can unlock unprecedented performance and an incredible developer experience for web developers. And that experience starts with JavaScript and TypeScript. With 2.0, SpacetimeDB now has first-class support for both TypeScript and JavaScript modules and clients. Internally, SpacetimeDB uses the state-of-the-art V8 JavaScript engine to execute your modules directly inside the database for never-before-seen performance in JavaScript web applications. SpacetimeDB makes it stupidly easy to build complex real-time applications with almost no effort at all. Apps that used to take weeks of work now take only minutes. In fact, let's build one right now. We've got 9 minutes and 38 seconds left in the video. More than enough time. How about a real-time chat application? Normally for an app like that, you'd have to spend time setting up a database, an ORM, WebSockets, a wire format, a relay server, and serialization just to even get started. With SpacetimeDB, all of that is just gone. We write our app's backend as a SpacetimeDB module. A module is just a JavaScript or TypeScript program that we bundle and upload to run inside the database. It defines both our tables and our functions, which implement our app's server-side logic. Then using our powerful SDKs, clients can connect to SpacetimeDB and call functions directly on the module, or subscribe to data as it changes in real time. Let's get started by defining our tables. Here we have public tables for users and messages, each with a few fields. Once we've defined our tables, we can write our type-safe server functions. This reducer inserts our message into the table after validating the text. Reducers are functionally the same as Node.js or Bun endpoints. This is where you write all your authorization logic, but you don't have to worry about ORMs, connection pools, or even transactions. Every reducer is transactional and atomic by default, completely eliminating whole classes of error handling bugs that could put your app into an invalid state. On the client, SpacetimeDB handles your connection for you and is automatically real-time. For example, in React, a simple use table hook subscribes to the server-side state and ensures your app re-renders anytime the results change. To send a message, our client can just import our type-safe send message reducer with use reducer. Calling this function will hit our module's reducer endpoint. That's it. That's all there is. Now we have a fully functioning real-time chat app. And if you prefer something other than React, we've got you covered. We've built integrations with all the most popular backends and frameworks. But we can even get a little fancier. With SpacetimeDB 2.0 procedure functions, we can even hit an external API. Let's call the ChatGPT API right from within our module. We can have ChatGPT respond to all messages that start with /ask. But how would we do private messages? Well, let's modify our message table to make it private and add an optional queue column. Now we can have view function, which returns only messages that are addressed to the caller of the view. In your modules, views are a function, but from the client's perspective, they work just like a table. This is all we need for real-time private messages. We can also query them like any other table, for example, by using Spacetime SQL. In fact, since SpacetimeDB 2.0 is Postgres Wire Protocol compliant, we can just use our favorite Postgres client. In just a few minutes, we've built a real-time chat web app with private messages and AI integration. You can build the same app right now on our homepage, or get started by running Spacetime Dev. We have a whole host of templates set up for you to easily get started at spacetimedb.com/templates. Spacetime Dev initializes your project with a highly tailored cursor rules file. So you can just ask your favorite LLM agent to build your app for you. And it won't necessarily be slop either. SpacetimeDB improves the success rate of LLMs at one-shotting web apps like this one by as much as 15% with the latest models. Because SpacetimeDB manages all the infrastructure, both you and your LLM can focus on just your application's core logic. Once you're done, deploying to our production main cloud environment is as simple as Spacetime Publish. In just a few seconds, users will be able to use your production application. The best part is, deploying to main cloud is now completely free. With 2.0, we're announcing all new pricing for SpacetimeDB main cloud, including a generous free tier. SpacetimeDB gives you detailed insights into your usage and spending with our energy credit system. The free tier gives you enough energy to run more than 1.5 million reducer calls per month. We think most apps will never need to go beyond this. And our Pro tier, for just $25, gives you 40 times more energy per month without any additional charge. That's over 65 million reducer calls before any pay-as-you-go charges. More than enough for even relatively high-traffic websites and apps. Our Pro tier also offers advanced features like automatic replication and advanced analytics. For startups and scaling teams, our main cloud team tier offers a great option for medium or large organizations, with an even higher energy credit, the ability to reserve an organization name, and advanced developer permissions for managing teams. Sign up for the team tier at spacetimedb.com/pricing to reserve your organization name today. We're also announcing the limited time Space Race referral program. For the next 12 weeks, you can permanently increase your free monthly credit by up to 400 times by referring friends to SpacetimeDB. That's up to 650 million reducer calls per month, free forever. Check out spacetimedb.com/spacerace to learn more. And with our new web dashboards and analytics, it's never been easier to manage your app's energy usage and billing. The online dashboard provides you a beautiful interface to call functions, monitor logs, or view your tables as they update in real time. And that is just the tip of the iceberg. SpacetimeDB 2.0 is shipping with all new docs, new features like event tables, a first-party auth solution, and so much more. We even have a collection of new video tutorials to help you get started building your apps in TypeScript. We're so excited to see what you build with SpacetimeDB. There is one more thing though, isn't there? We haven't talked about performance yet, and as game devs, I like to think we know a little something about performance. So how does SpacetimeDB handle a web workload? Well, traditionally your server is separated from your database by the network. In order for your server to access your data, you've got to serialize a query, send it, go all the way through the OS stack, over the network, up the OS stack, receive, parse, plan, and execute, and then go all the way back, all while holding open a transaction and potentially locking up rows. Just pinging the loopback port on my machine without any database work reports an average round-trip time of almost 200 microseconds, with a max of more than 1 millisecond. That's without even touching the network. In SpacetimeDB, your database is your server, so accessing your data takes nanoseconds instead of microseconds, or even milliseconds. That's at least 1,000 times faster. In other words, this is not to scale, this is to scale. So what does that mean for your apps? Well, let's imagine a simplified banking app. We have a set of accounts and we want to process valid transfers between accounts. To simulate a real-world scenario, accounts are chosen at random, but skewed towards popular accounts that have many transfers. Here's the code in Spacetime DB. Let's run some benchmarks against traditional backends with 50 clients running on separate machines making concurrent requests. Newer hosted solutions and all-in-one platforms struggle. Convex, with its dozens of transactions per second, goes toe-to-toe with pen and paper. Postgres, on planet scale, doesn't offer co-location and pays the price. Supabase only manages to achieve roughly 1,300 transactions per second. But even with multiple servers, the traditional Node.js and Postgres setup tops out at 4,000 transactions per second. Bun does about 20% better. Clearly our problem is that we need something that scales horizontally, right? We need something web scale. Well, CockroachDB on a 5-node cluster only hits roughly 400 transactions per second. Distributed coordination actually slows us down, despite the much higher AWS bill. Only SQLite with its embedded architecture similar to Spacetime DB beats Postgres. That's fun, but what does real speed look like? How fast is Spacetime DB? Allow me to answer that question with a question. Do you like my car?
Because I'm waiting for you. It's gonna be so exciting. Got this feeling really deep in my soul. Let's get it, I wanna go. Come along, get it on. Gonna take my car, gonna see it. Gonna drive along till I get you. 'Cause I'm crazy about you, baby. Yeah, you like it. I wanna race for you. Shall I go now? Yes, yes, yes. I'm gonna step on the gas. And be a lover. I'll be so quick as a flash. And I'll be your hero. Yes, yes, yes. I'm gonna run as a flash. To be the winner. I'm gonna step on the gas. And see the big show. Yes, yes, yes. Yeah, yeah, yeah.
Okay, and now everything between database, business logic, and client various operating systems. If they're doing exactly what you're not supposed to do, it's a contradiction. So they know that README, it is as simple as npm install. This has so detailed in the README and hardware. Wow. No surprise, client, they are so it allows the case is that process of bench sits in called in their original server. So this would mean is I remove ID. They don't have a version Go client, and runs the benchmark itself. Now the other this balance is which fits the database you get. Here's the RP or my career reduce to for procedure for transferring between two accounts. If there's no that it's easily do compare plus you get very surprising 100K compared to that with the various configurations here was 100-ish K. I think 100 dial somewhere in the background. I don't have this results. I can get Postgres up to 156 TPS, which is even higher than their number running on bigger machines. Spacetime DB maxes out with the native client. At least I think increases at least 2 or 3 times the throughput. And yeah, obviously, this is true that Postgres compared to NoRPC is 14 times faster, but this is the interesting part, that this is at least 3 times faster. So, yeah, compare apples to apples and know your architecture and know what you want to do before doing.
Every deployment Postgres plus an RPC server in front of it. The point of benchmark is that space-time fills both roles in for you by default. This ends up being the more opposed to oranges than the original benchmark because it compares a full backend on half a backend. Love to deep dive though. Will be posting a response. I thank you for the response. I think creating a power specification for what you want to measure and what feature properties do you require from systems would be way to continue this argument. I think your benchmark is a way to show how space-time fills both DB and RPC server role, but it does not give a chance for other systems. Just a ROS client and ROS RPC PostgreSQL approach should achieve the comparable TPS, but I don't know that neither of us did the comparison like that. The point of this benchmark is that PostgreSQL can beat space-time TPS with the stored procedures. I have to agree with you that if you consider not so much used RPC hub the space-time in your the benchmark, I am indeed comparing your pool apple to my half orange. Look forward response. The difference in their performance is perfectly realistic and exploitable. They are not doing any black magic. That overwhelming difference in the speed is simply that one would expect for the way their backend is architectured. One comes from the cost of other things such as more complicated or impossible horizontal scaling and the high price of vertical scaling because of the cost of memory, but their benchmark is perfectly fair and changing the RPG from TypeScript to Rust will have no difference in performance. Is exactly the problem with Unit. The comparison is for the web devs, it's not for the raw database throughput because it's not a practical measure for the web devs. Then why did they measure raw database TPS? Literally transaction per second instead of end-to-end request. At the whole point of the space-time would be that if you add your business logic that would run in the separate server and stays fast, that they did not resorting to last indicates the weak argument, and that's what the whole space-time fluff seems.
Spacetime DB is a new database which I recently came across. I have heard their name in the past, but I did not pay a lot of attention. But they have been making a lot of noise on Twitter, especially because of this very interesting and funny benchmark that they released. I also tweeted about this. I mean, this is just borderline insult for Convex and Node.js plus PlanetScale and CockroachDB. We're just having a magnifier here, right? It's a little insulting, but it's also funny that they had to use this magnifier in order to show the exact value that these databases are on in this performance benchmark that they have created. Now, this benchmark is absolutely bonkers. If you look at this Spacetime DB plus Rust is actually at 167,000 transactions. I'm assuming per second, right? These are transactions per second. Yes. On the other hand, they have given Convex only 123 transactions per second. That's like 1,000x difference, right? A difference of 1,000 times in performance is mind-boggling. It's absurd if you are considering like a real life use case. But of course, this is not the full story. And I've spent a little bit of time understanding their architecture as well and some other tweets and what people have been saying. So I want to spend a little bit of time in this video walking you through what Spacetime DB is, if this is a good fit for you, what are these benchmark numbers exactly. So let's talk a little bit about this. So first things first, what you have to understand about typical databases approach, typically like how people build backend systems, is that they will have a backend over here, which is your actual server, right? Which is written in whatever language preference you have, could be Node.js, Go, Rust, whatever you have. Then this backend server actually connects to database in case if it is like a Postgres like of database, which limits the number of connections you can have, then this would be something like a PG bouncer instance, right? Which will maintain like a sort of like a highway of connections with the actual database over here, and your application talks to PG bounces, and there could be like multiple variations of your backends. So you can have like, let's say 10 backend servers running, all talking to the same PG bouncer over here. These backends could be serverless also. They could be like actual servers as well. And PG bouncer maintains sort of like a connection highway with your database. What Spacetime DB is suggesting is something else entirely, and about typically like,
Oh my God, so sorry. I think I need to stop here because yeah,